What's going on, everybody? Welcome back to my YouTube channel. We have a math question which says find all the values of a for which a to the 6 minus 64 is equal to 0. Well, our first step will be for us to split 6. So this expression can be written as a to the 6 is same as 3 times 2 minus 64. 64 is a perfect squared, which means it can be written as 8 squared. And this is equal to 0. Now, from indices, whenever I have, for example, x to the m times n, this can be written as x raised to the m, and this raised to the n. So we're going to be expressing this like this. So this expression now becomes a to the 3, then raised to the power of 2, minus, this is 8 squared, and this is equal to 0. Now notice that we have difference of two squares. And difference of two squares, for example, can be expressed as x squared minus y squared is equal to x minus y times x plus y. So let's express this like this. So that means we're going to have a cubed minus 8 times a cubed plus 8. So we've been able to express this difference of two squares like this. And this is equal to 0. So equal to 0. So we have two cases. The first case, let's call this case 1, is where we have a cubed minus 8 to be equal to 0. Or for the second case, let's call this case 2. This is where we have a cubed plus 8 to be equal to 0. So we're going to be solving these cases one after the other. So we start with the first case, case 1. So for case 1, this is a cubed minus 8 is same as 2 to the 3, and this is equal to 0. So now notice that we have difference of two cubes. And for any difference of two cubes, for example, when we have x cubed minus y cubed, this can be expressed as x minus y times x squared plus xy plus y squared. So let's express this difference of two cubes like this. That means this expression can be written as a minus 2 times a squared plus 2a plus 2 squared. So we've been able to express this in difference of two cubes to get this. And this is equal to 0. Now let's simplify what we have inside of this bracket. So we have a minus 2 times a squared plus 2a plus 2 squared is 4. And this is equal to 0. So we have two cases here. And for the first case, a minus 2 is equal to 0. Or for the second case, a squared plus 2a plus 4 is equal to 0. So we can easily get the solution to a from the first case by moving negative 2 to the right hand side. So a now becomes, as negative 2 crosses to the right, it becomes positive 2. So we have the first real solution of a. Now to get other values of a, we move to this other case. And when looking at this case, you see that we have a quadratic equation. So what is our A from this quadratic equation? Since we're going to be using the quadratic formula, our A is the coefficient of A squared, and that's 1. Our B is the coefficient of A, and that's 2. And our C is the constant term, which is 4. Now we're going to be using this quadratic formula. Since we're looking for A is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. Now let's substitute into this quadratic formula. So the value of A now becomes negative B. B is 2 plus or minus the square root of B squared. B is 2, so 2 squared minus 4 times A times C. So 4 times A is 1, times C is 4. So put down 4 there. Very good. All over 2A, which is 2 times 1, since A is 1. So we have A to be equal to negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 1 times 4 is 16 all over 2 times 1 is 2. So this becomes A equal to negative 2 plus or minus the square root of 4 minus 16 is negative 12 all over 2. Very good. So this becomes A equal to negative 2 plus or minus the square root of negative 12 is same as 4 times 3. 4 times 3 is 12, and then times negative 1, which makes it negative 12 all over 2. So this becomes A equal to negative 2 plus or minus. Well, we're going to be separating this into the square root of 4 times the square root of 3 times the square root of negative 1 all over 2. Very good. So A now becomes negative 2 plus or minus the square root of 4 is 2. So 2 times the square root of 3 gives 2 root 3. And then times the square root of negative 1. The square root of negative 1 is actually iota. So we're going to be putting iota there to multiply this expression all over 2. Now notice that from the numerator, 2 is actually common. So we have to factor out 2, making A to be factor out 2, 2 out, open bracket, negative 2 divided by 2, we have negative 1, plus or minus 2 root 3i divided by 2, we have root 3i. Very good. All over the denominator, which is 2. So 2 here can cancel out this 2, making the value of A to be equal to negative 1 plus or minus the square root of 3i. So there are actually two values of A from here. We have A, which is going to be the second value or second solution we've got for A, to be equal to negative 1, going with a positive, plus root 3i. And then the other one, which is the third solution for A, is negative 1. This time, go with the negative minus the square root of 3i. And these are 3 solutions we've got from our first case. Now for our case 2, do you remember case 2? Case 2 is where we have a cubed plus 8 to be equal to 0. Well, this expression can be written as a cubed plus 8 is same as 2 cubed, and this is equal to 0. So notice that we have an expression in the sum of two cubes. An expression in the form of two cubes can be written as, for example, when I have x cubed plus y cubed, this is same as x plus y times x squared minus xy plus y squared. Now let's write this expression in this form. That means this can now become a plus 2 times a squared minus 2a plus 2 squared. Very good. And this is equal to 0. So we have two cases. For the first case, we have a plus 2 to be equal to 0. Or for the second case, we have a squared minus 2a plus 2 squared is 4, so plus 4 equal to 0. Now it is easy for us to get the value of a from this first case by moving 2 to the right hand side, so that the value of a now becomes, as 2 crosses to the right, it becomes negative 2. So this is our fourth solution for a, and is a real solution. Now, looking at the second case, you'll notice that this is a quadratic equation. So we're going to be using the quadratic formula to solve this. So from this quadratic equation, we see that a, which is the coefficient of a squared, is 1. b, which is the coefficient of a, is negative 2, so negative 2. And c, which is a constant term, is 4. So since we're looking for a, we're using the quadratic formula, which is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute this inside of our quadratic formula. So we have a equal to negative b, so negative b is negative 2, so I'm going to be putting that in a bracket, plus or minus the square root of b squared, that's negative 2 squared, since b is negative 2, minus 4 times a times c, so 4 times a is 1, times c is 4. Very good. All over 2 times a. 2 times a is 1. Very good. So now let's simplify further. This makes a to be equal to negative times negative gives positive 2 plus or minus the square root of negative 2 squared is 4 minus 4 times 1 times 4 is 16. All over 2 times 1 is 2. So this simplifies into a to be equal to 2 plus or minus the square root of 4 minus 16 is negative 12 all over 2. Very good. So a is equal to 2 plus or minus. Now negative 12 can be simplified into 4 times 3 times negative 1, which results to negative 12 all over 2. Now separating this, we have a to be equal to 2 plus or minus. This becomes the square root of 4 times the square root of 3 times the square root of negative 1 all over 2. Very good. So finally, a becomes 2 plus or minus the square root of 4 is 2 times the square root of 3. So we leave that like that, root 3. Now the square root of negative 1 is iota. So we leave that as I. Very good. All over 2. We can't leave our answer like this because we can actually factorize the numerator. So 2 is common, so let's factor out 2. So A now becomes factor out 2, open bracket, 2 divided by 2, that's 1, plus or minus 2 root 3i divided by 2, we have root 3i, all over the denominator, which is 2. So 2 can cancel out 2, leaving behind what we have here, which is equal to 1 plus or minus root 3i. So there are actually two solutions here. So we have the fourth solution for x, for a rather, to be equal to 1. Go with the positive plus the square root of 3i. Then this is supposed to be the fifth solution rather. Then the sixth solution, we call this a6, which is equal to 1. Now go with the negative minus the square root of 3i. So we've got 6 solutions for A, where 2 are real solutions and 4 are complex solutions. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.